So our first lesson in Unit 6, Part 2, we're going to start talking about solving quadratic equations, and that really starts with identifying what the heck is a quadratic equation, and then we're going to learn one of the most basic ways and the easiest and fastest way to solve a quadratic equation. So we've been dealing a lot with polynomials so far in Unit 6, Part 1, so now we're going to talk about what happens when that polynomial is in an equation. So we're going to throw an equal sign into the mix. So to start off with our warm-up here, I thought maybe we could do a little mental math. I bet you guys know a lot of the answers to these already, and I just want you to kind of go back and think about Unit 5 with our radicals and our square roots and things like that, and see if you can't use mental math to figure out what the answers to these three equations would be. So if we think it says x squared equals 9, so we're trying to say, okay, what times itself equals 9, right? That's what this equation is all about. That's what it's asking. What number times itself equals 9? So I bet immediately into your brain pops the answer, well, it has to be 3, right? 3 times 3 equals 9. So x would have to equal 3. For sure, 3 times 3 does equal 9. But I wonder if any of you thought of the second answer that also exists. There's another number times itself that would also equal 9. And that second number would be -3, right? -3 times -3 also equals +9, right? So when I have this number squared, if I take a positive number times a positive number, I get a positive answer. When I take a negative number times a negative number, I get a positive answer. So we never really talked about this before. We threw some equations that had x squareds in them at you when we did Pythagorean theorem and things like that. But in that case, we were talking about triangles. You don't really have a negative answer anyways. But now we want you to really think outside and think of all the possibilities. So if I had the equation x squared equals 9, it would really have two answers, right? 3 and -3, because both of those things times itself would give you +9. Now, back when we were talking about it before, remember we talked about if we were going to show our work for this, we would really do the opposite of squared to get x by itself. And the opposite of squared is to take the square root. And that square root really means what number times itself, right? Equals 9. So when we're looking at the equation now, we're just kind of thinking of all the possibilities, and that's what kind of opens up when we get this idea of an equation. So number 2, now that we thought about that one, let's see. What number times itself equals 144? Or if I take the square root, I'm writing the square root in order to solve. These guys will cancel out. I will get x equals what? What number times itself gives us 144? Definitely positive 12, right? 12 times 12 equals 144. And also -12. So -12 times -12 equals 144 as well. So there's my two answers. Notice when I have an x squared, I do have two answers. Now, I'm not sure if you have ever seen this before, but since we're looking at these, I have a +3 and a -3 in my first one. I have a +12 and a -12 in my second one. We do have a symbol to show that positive or negative are both options. And so I could write this as x equals plus or minus 12. I'm not sure if you have seen that plus or minus symbol before, but either one of these ways to write the answer, that means the same thing. So here we could write plus or minus 3 if we wanted to, or we could write it out separately like we did up top and write 3, -3. They mean the same thing, but you might see the answer written either way in this unit. I'll also give you some suggestions on maybe when one way might be better than the other, but definitely both are always great ways to write your answer. Number 3 is a tricky one. What number times itself gives you -36? Well, I bet the number 6 popped into your head, but hang on. 6 times 6 gives me +36, not -36. Okay, how about, all right, negative 6 times negative 6. Oh, wait, that gives me positive 36 as well. There's no way that I can take a number times itself and get a negative answer. It just doesn't work, right? So this one is no solution, and we are going to have to watch out for these in this unit. You can never have something squared equal a negative number. It just doesn't work. It doesn't happen in the real world. Next year, or maybe the year after, you'll get into this possibility of the imaginary world, but right now in this chapter, in this unit, we're just going to deal in the real world. And so there is no real number that exists that I could multiply times itself and get a negative number for an answer. Now, hopefully you'll be, on top of your game and you'll notice it when it looks like this. But sometimes you'll miss it right away. But as soon as you write this square root sign on here in order to solve, we cannot ever take the square root of a negative number. Can't ever have the square root of a negative number. So hopefully at that point then, it will start ringing some bells for you. You'll stop right away and you'll write no solution, okay? Can't take the square root of a negative. If you see it a step even before that where it says x squared equals a negative, you'll know that that's not going to work either. All right, so kind of a warm-up, getting you in there, using that mental math, but also realizing that these types of equations, when I have x squared, are going to have two answers, positive versions and negative versions. And we can't ever have x squared equals a negative number, so there will be some no solution possibilities. All right, so let's give these equations a name, right? These equations that have an x squared, a degree of 2. Remember last unit we talked about the degree of a polynomial, right? That was the highest exponent, or I should say, like the highest degree of any of its monomial terms. And so in this case, like the highest exponent has to be a 2, and I can't have more than one variable, right? So I can't have x squared y, that would be a degree of 3. So these we're talking about anything that has that x squared in it and nothing higher than x squared. If there's an exponent that's higher than x squared, it gets a different name. So we are going to focus on this entire unit on equations that have that x squared but nothing higher, and those are called quadratic equations. You are going to hear that term a whole bunch. We're going to use it all of this unit, all of next unit, because in the next unit we're going to learn how to graph these crazy equations. But get really comfortable hearing that word quadratic and knowing that it means that it contains an x squared and nothing higher. So you can see down below in this orange box that I have 3 examples of a quadratic equation. They can be pretty crazy when I have 3 terms like this, negative 2x squared plus 4x plus 10 equals 0. But notice, here's my x squared, right, and nothing higher. I could have x squared minus 16 equals 0. Notice, I don't have an x term in this one, but I still have an x squared, and so it's still a quadratic, right? I don't have to have x squared and x. I just have to have this degree of 2, and that's it, okay? The next one, I have x squared plus 2x equals 20. Still has an x squared, still a quadratic. It's just not in that same form where it equals 0. Now, some equations in this unit, we're going to really want to make sure that they equal 0 because that's a special way to solve it. Some of them, they don't have to equal 0, and so we'll talk about that as well. So there's definitely different ways that the equation can be written. So let's start talking about these different quadratic equations and ways to solve them. So we're going to look at these types of quadratic equations where they don't have an x term. Here's my x squared, right? So it is a quadratic, but there's no x term here. I have my x squared, and then I just have numbers other than that. And so this is the way to solve these is by using square roots, just like we did in our warm-up. Now, we can't use a square root if there is an x term as well. So like that first example or the last example up in that orange box, I would not be able to use square roots to solve those. That's coming up in a different lesson. But for today, we're just going to learn when there's no x term, I can use a square root to solve it. And that's the method we're going to talk about. Okay, so I'm guessing that you have a pretty good idea of how to do this already based off of our warm-up, right? In our warm-up, the x squared was by itself already. So in these equations, the x squared isn't by itself yet, so we just have to move some stuff around in order to get the x squareds by itself. So in number 1, the first thing to do to get that x squared by itself is to add 8 to both sides. I'll get 2x squared equals 8. X squared isn't quite by itself yet. It's close, but not quite. I have to divide both sides by 2 before I can do any square roots. That x squared has to be completely alone. Now that x squared is all by itself, and I'm guessing you're thinking back to that warm-up and you're already using mental math, but please make sure from here on out that we are showing our work. What is the opposite of squared? The opposite of squared is to use a square root, and you have to show that square root. If you don't, oh, it's so easy to make little mistakes like saying that x still equals 4. X doesn't equal 4. X equals 2. Or, remember what else times itself equals 4? -2, right? So don't forget that you're going to have these two answers for these quadratic equations, right? 2 or -2. And remember that you could also write that as plus or minus 2 if you wanted to. Those are both good ways to write your answers. So take a look at number 2. See if you can do that one on your own. First thing I gotta do is add 25 to both sides. I get x squared equals 36. All right, now I need to undo that squared, so I'm going to write my square root sign. Make sure that you write the square root sign as well. Squared and square root cancel. I get x equals 6 or -6, right? Both of those multiply by themselves to give me 36. And again on this one, you could write x equals plus or minus 6 as your answer. Either way is perfectly acceptable. All right, let's take a look at a couple of more. Number 3, hopefully starting to get pretty used to this. Subtract 12 from both sides. I get x squared equals 28. Okay, take the square root. Hang on, I'm sure you're starting to freak out a little bit. 28's not a perfect square. Remember though, we spent an entire unit talking about what to do if you have a square root of a non-perfect square. You know how to do this. It's not a no solution. You don't just leave it as 28. Remember that you have to break it into its factors, where one of those factors is a perfect square. This would break into square root of 4 times the square root of 7. The square root of 4 is a perfect square, so I get 2 radical 7. But don't forget, this is still a square root, right? We said what times itself could give us 28. Sure, 2 radical 7 times itself would give us 28, but so would -2 radical 7. So even if it's not a perfect square, even if you have a radical in your answer, you still need positive or negative. So you could also write this as x equals plus or minus 2 radical 7, like that. Okay, so don't forget that even if it's not a perfect square, you can still write it, or you still have to write it with the positive or the negative. All right, now in number 4, it looks a little bit different. It says x plus 5 in parentheses squared equals 36. Now, I know it's not just a plain x squared, and we can't distribute our exponent here because I have this plus sign. Remember back in the last unit, remember what it would actually mean if I had x plus 5 squared? It means x plus 5 times x plus 5. Do you remember how we would have to multiply that? We'd have to FOIL. Yuck. Ugh. Okay. So that's way too much of a mess. I don't want to do that here, and I can't just distribute my exponent because there's that plus sign in there. It's a binomial. But do you notice how it's just this big thing squared on the left? There's nothing outside of the square. There's nothing to move. Everything is trapped inside the parentheses. So I think that right away, first thing I could do is to take the square root. Since there's nothing outside, this squared and square root are going to cancel out, and I'll have x plus 5 equals 6 or negative 6. Remember, whenever you take that square root, there has to be those two different answers, no matter if it's the first step or the last step. Okay, this is the trickiest part about this one. So you have to make sure that you have that plus or minus the next step after you write that square root sign. It's not always going to be the last step. So just notice the difference between number 3 and number 4 right now. Okay, we had a plus 12 on the first one. We had a plus 5 on the second one. But notice, on the first one, that plus 12 was outside of the squared, right? I had to move it to get whatever was squared by itself. On the right one, on number 4, it was inside the parentheses, that plus 5. That's why I could take the square root right away. And just remember, whenever you take that square root, that's when you have the plus or minus and the very next step. So this time, it was not my last step. Now at this point, I highly recommend that you don't use the plus or minus symbol. I highly recommend that you write it as two different answers with a comma between, like I did right here, 6, negative 6. And the reason is because if you look on the left, I still have to move that 5. I'm not finished with my equation. I have to subtract 5 from both sides. But that means that I have to subtract 5 from both of my possibilities, right? I have to say, okay, well, x plus 5 could equal positive 6, and x plus 5 could equal negative 6. So when I move that 5 over to figure out what x equals, I have to subtract 5 from both parts. 6 minus 5 gives me 1. Negative 6 minus 5 gives me negative 11. Notice, I still have two different answers, but it's not plus or minus of the same number, and that's okay as well, right? So if your square root step isn't your very last step in the equation, then you're not going to have the same number, just positive and negative, but you should still have two answers. Many times it'll be one is positive and one is negative, but not always. But they won't be the same number unless the square root is your very last step. So a lot of times that square root is your last step, but not always. All right, so the next one here. Notice I have my parentheses squared again in number 5 and in number 6. So same idea here, right? What we're trying to get is the parentheses squared by itself. But notice in number 5 here, I actually have 2 in front of the parentheses. So the parentheses is not by itself yet. So you might be thinking that I would distribute that 2, right? But be careful, that would be multiplying. And I notice that I have an exponent. And if we think of our order of operations, what has to come first, multiplying or exponents? And the answer is definitely exponents, right? So I can't distribute because it would be doing multiplying before exponents. So what I have to do is get rid of that 2 in a different way. Remember, it means multiplying when that number is outside the parentheses, right? So if I want to get rid of it, I would just divide both sides by 2. And then that would cancel the 2's out on that side. And I'd be left with my parentheses squared equals negative 16. Hopefully you're seeing some warning bells already going off in your head, right? But if I say, okay, now whatever squared is by itself, I'm going to take the square root. Whoa, now you should have some serious warning bells going, hang on. I cannot take the square root of a negative number. There is no such thing, and nothing. It doesn't matter what number it is that would be times itself that would give me a negative answer. So hopefully that one jumped out at you right away. This one has to be a no solution. So don't forget, we talked about that in the warm-up. Don't forget to watch out for those. They'll sneak up in you at random places. So remember, nothing squared can ever equal a negative number, which means that you can never take the square root of a negative. So let's look over here at number 6. Maybe this one will work out. So I see 3 outside the parentheses. My parentheses are squared, and it equals 18. So just like we talked about in that last one, I can't distribute the 3. I need to divide both sides by 3. So I'm left with x minus 5 in parentheses squared equals 6. Now this time I have a positive number, so I think I'll be okay. Now my parentheses are all by themselves. My thing that's squared is alone, so I can take the square root now. So square root and squared will cancel out. I'm left with just x minus 5 on this side. Ooh, 6 is not a perfect square. That's okay though. I can't simplify it. 2 and 3 are the factors, but neither one are a perfect square, so it's just going to say a square root of 6 or the negative square root of 6, right? Remember, even if it's not a perfect square, you still have a positive and a negative version as your answer. Now I still need to move this 5 though. So I need to add 5 to both options over here on the right. And just remember, I really wanted to do this one for sure with you, because remember that anything that's on the outside of the radical has to go in the front of the radical. I can't say radical 6 plus 5 because then I'm not sure. Wait, is your radical supposed to go over the 5 or not over the 5? Did you just not write it correctly? So anything on the outside of the radical has to go in front. So that means in this first one, it's a positive 5 plus radical 6 because it's a positive radical 6 as well. In the second one, it's a positive 5 minus radical 6 because that was the negative radical 6. So you see how those are written. You could also have, instead of writing the radical 6 and negative radical 6 separately, you could have done the plus or minus, and in that case then that positive 5 would still have to be out in front, and then you'd have the plus or minus and then the radical 6. Do you see how those are kind of the same thing, right? 5 plus radical 6, 5 minus radical 6, or 5 plus or minus radical 6. Just remember, if it's outside, it has to be in the front. It can't be radical 6 plus 5 because then it's confusing and if it's supposed to be inside the radical or not. All right, that is about as complicated as it gets, but now we have time for a little real-world situation. When are you going to see these types of equations? So, a contractor is building a fenced-in playground at a daycare. The playground will be rectangular, with its width equal to half of its length. The total area will be 5,000 square feet. Determine how many feet of fencing the contractor will use. All right, so first I have to draw my picture. So here's my rectangular playground, right? It says the width will equal half of its length. Now there's two different ways to do this, and I've seen both ways that students do this in the past. To me, the more obvious one is this. Okay, if the width is half of the length, let's say, okay, here's the length. The width would be half of that, right? Width is half the length, so length and half the length. It says the total area will be 5,000 square feet. How do I find the area of a rectangle? I multiply the length times the width, right? So I'd have length times 1/2 length has to equal 5,000. All right, well there's my equation, right? I can solve that. L times 1/2 L. Remember, this is like L to the first times L to the first, right? This would be 1/2 length squared. L times L is L squared. It's not 2L. Remember that, okay? We're multiplying, not adding. So I have 1/2 L squared equals 5,000. I gotta get rid of that 1/2. How do I get rid of fractions again? I clear the fractions by multiplying by the denominator. So I'm gonna multiply both sides by 2. My 1/2 is gone, so I have L squared equals 10,000. Now I take the square root, right? Now I'm writing in this square root sign, so I think what times itself gives me 10,000. That is a perfect square, so I get, could be 100 or negative 100, right? Don't forget, you have a positive and a negative answer. You always have those two possibilities whenever you have a quadratic there with that squared. Now, I'm thinking of a real world situation here though, right? This is about the length of a playground. Could I have the length of a playground be negative 100 feet? No, I can't have a negative, right? No negative side lengths. But it still needs to be in my work. Sometimes you are going to have a real world situation where a negative answer makes sense. And if you don't write it in your work, you will not have it when you need it in a situation like that. So you have to write it in your work. Think about your answers. Do both make sense? If one of them doesn't make sense, cross it off, okay? So that means the length has to be positive 100, which means that the width is half of that, which would be 50. Now, is that what the problem was asking for? Wait, it says determine how many feet of fencing. How many feet of fencing the contractor will have to use? Well, let's see. I have, that's 100, so then the other side would be 100. The width is 50, so the other width would be 50. So that means I would have 2 100s plus 2 50s, right? If I was going to find the perimeter, that's how many feet of fencing we would have to use. So that would be 200 plus 100, which would equal 300 feet of fencing is what we needed for that. All right, so there's a real world quadratic in action, and you can see, like, sometimes you're probably like, these word problems, that's never going to happen. This really does happen. You really do use these things in all kinds of careers. So this is one of those that is important to understand. Just to wrap it up, a quadratic equation is any equation that contains an x squared but nothing higher, right? Degree of 2. Solving a quadratic equation using a square roots, make sure that you get that x squared or whatever is squared by itself before you take that square root, right? If it's parentheses that are squared, get that parentheses by itself before you take the square root. Remember that your answer can be positive or negative that step after you take the square root, right? If it's your first step, then you're going to have a plus or minus throughout your whole set of work. If it's your last step, then you're just going to have a plus or minus, boom, right there at the answer. And you can never take the square root of a negative number in the real world here, right? So if you see something squared equals a negative, or you're starting to write that square root sign over the top of a negative number, no solution. Stop right there. All right, there's your first introduction to quadratic equations.